In this presentation, we will get a brief introduction to logic gates. So what are logic gates? Logic gates are the building blocks of digital circuits. They combine binary inputs to produce a binary output, a 0 or a 1. They implement the basic logic operations a computer can perform, and, or, and not. More complex logic can be implemented by combining these operations in ever more complex circuits. Let's take a brief look at the AND logic gate. Let's talk about the AND gate, one of the three basic digital logic gates. The AND gate looks like this. This is the symbol we use to represent this logic gate. Like all logic gates, it has a certain number of inputs and an output. We're going to label these inputs as A and B. And we'll label the output as C. Now, A and B are nothing more than bits. The output, C, is also a bit. The gate transforms the inputs into this single bit. The way we sort of gauge what the effect of the AND gate is we use truth tables. Now, truth tables are nothing more than a mapping from a set of inputs to an output. Since we have two input signals, there are four possible combinations of bits. 0 and 0, 0 and 1, 1 and 0, and 1 and 1. Now, the effect of the gate is what we see over here with C. The AND gate only produces a 1 for one combination. When both of the input signals are 1, we get a 1 as the result. Any other combination is 0. And that's the effect of the AND gate. Given a set of bits, it will produce a 1 when both of the input signals are 1. Now let's take a look at the OR logic gate. The OR gate is slightly different than the AND gate. The OR gate is a lot more forgiving. The OR gate symbol looks like this. Again, just like the AND gate, it has two inputs and a single output, which we will label with the same letters. A and B for the inputs and C for the output. Now, the truth table for the OR gate looks like this. As with the previous gate, we have four possible combinations. 0, 0, 0, 1, 1, 0, and 1, 1. Now if you recall, with the AND gate, we only had a 1 in this column for one combination. For OR, it's a lot more forgiving. For OR, we have a 1 for three combinations. OR means that if either A or B or both are 1, the result or the output is going to be a 1. So the only time we get a 0 is when neither A nor B is 1. In every other combination, as long as we have a 1 either for B or for A or for both, we get a 1 in the result column. Finally, let's examine the NOT logic gate. The third and last of the basic logic gates is called NOT. Now, unlike AND and OR, NOT only requires a single input and produces a single output. The symbol looks like this. Now for this, since we only have a single input, we'll label that as A. Now we'll also call the output C to be consistent with the other gates. Now this particular logic gate, you can think of as an inverter. It takes the input signal, the input bit, and changes it. If it's a 1, it makes it a 0. If it's a 0, it makes it a 1. So our truth table is very simple. We only have 2 possible signals coming in on the input line, either a 0 or a 1. The output simply takes whatever signal is given and flips it or inverts it. If it's a 0, we produce a 1. If it's a 1, we produce a 0. So the NOT gate, the NOT logic gate, is simply an inverter. It flips the bit.